In 1982, a construction worker in Florida picked up what he thought was a rock. It was a human skull. But that skull was about to unlock one of the strangest genetic mysteries in American history, because the DNA inside it belonged to no one alive today. It was a hot, humid morning near Titusville, Florida, on a stretch of land developers had marked out for a brand new housing project. A backhoe. Operator named Steve Vanderjacht was clearing out a shallow, muddy pond so construction crews could move in and start pouring foundations. It was routine work. Dig, scoop, dump, repeat. Nobody expected anything except mud, roots, and maybe some old farm debris. Then his shovel struck something hard, something that glinted strangely under the wet Florida sun. He climbed down to take a closer look, and what he found nearly stopped his heart. Staring back at him from the muck was a human skull. Not a fresh one, not a crime scene. Something that looked ancient, waterlogged, and strange, with a texture that didn't quite look like bone should look after being buried for a long time. He didn't touch it again. He called his bosses immediately, and to their enormous credit, instead of quietly filling the hole back in and continuing construction, the developers stopped everything and called in archaeologists. That single decision, made by ordinary people who could have just as easily buried the discovery and moved on, changed the course of North American archaeology forever. What emerged from that muddy pond over the following years would become one of the most significant, most bizarre, and most scientifically important archaeological discoveries ever made on this continent. It would be called the Windover Pond Site, and it would eventually yield the remains of over 160 ancient human beings, preserved in a way that should not have been possible in a hot, swampy, subtropical climate like Florida's. To understand why this discovery mattered so much, you have to understand what usually happens to a human body after death in a place like Florida. In most environments, especially warm, wet, oxygen-rich ones, a body decomposes quickly. Bacteria, insects, and the elements break down soft tissue within weeks. Bones might survive for centuries if you're lucky, but skin, organs, hair, and especially brain tissue are among the first things to disappear. Archaeologists studying ancient burial sites are usually thrilled just to find intact skeletons. Anything softer than bone is normally long gone. But Windover Pond was different because of a strange and specific set of environmental conditions that came together almost like a perfectly engineered time capsule. The pond had a layer of thick, anaerobic peat at its base, meaning there was almost no oxygen down there. Without oxygen, the bacteria that normally cause decomposition can't survive, or their activity slows to a crawl. The pond's chemistry, combined with the cool temperature underwater and the pressure of layers of peat and sediment building up over centuries, created an environment where soft tissue simply didn't rot the way it should have. It was preserved, almost frozen in time, sealed away from air and oxidation for thousands of years. When archaeologists led by Dr. Glenn Dorn of Florida State University began carefully excavating the site, what they found defied expectations at every turn. They weren't just finding bones, they were finding brains. Actual, intact human brain tissue, shrunken and darkened by time but unmistakably present, inside the skulls of people who had died 8,000 years ago. This was, and still is, considered one of the largest collections of ancient brain tissue ever recovered anywhere in the world. Alongside the brain matter, they found other soft tissues in some individuals, skin, stomach contents, even fragments of internal organs. They also uncovered woven textiles, some of the oldest known fabric ever found in the Americas, delicate plant fiber weavings that had somehow survived the same 8,000-year submersion that preserved the bodies. This wasn't Denmark. This wasn't the famous European bog bodies like Tulland Man, preserved by the acidic, tannin-rich peat bogs of northern Europe that many people have seen photographs of, with leathery brown skin still stretched over recognizable faces. Windover was something rarer and, in some ways, even more remarkable. A New World bog cemetery, in a place nobody thought this kind of preservation was even possible. It forced scientists to fundamentally rethink what environmental conditions could do to human remains, and it turned an ordinary forgotten pond behind a planned subdivision into one of the most valuable windows into prehistoric America that has ever been opened. As the excavation expanded, the sheer scale of what lay beneath the water became clear. This wasn't a single body, or a handful of remains from an isolated accident or tragedy. This was a cemetery, a deliberate, organized burial ground used again and again, generation after generation, by the same community of people, for what researchers estimate could have been centuries. In total, archaeologists eventually recovered the remains of 168 individuals, men, women, children, and infants. It was a complete cross-section of an ancient society, all resting together in the peat, waiting 8,000 years to tell their story. And what a story these remains had to tell. The people of Windover weren't randomly discarded into the pond. They were carefully, deliberately buried, based on very specific and consistent evidence found at the site. Researchers determined that the bodies had been placed into the pond within roughly 48 hours of death, likely wrapped in some kind of fabric or plant material, and then anchored to the bottom using sharpened wooden stakes driven through the burial wrappings. This wasn't a violent or hostile act. It appears to have been a careful funerary ritual meant to keep the bodies submerged in the peat, which, whether the Windover people understood the science behind it or not, is exactly what allowed those bodies to survive for thousands of years afterward. In a strange, almost poetic way, their burial customs accidentally created the very conditions that would preserve their bones, their tissue, and even their DNA, long enough for scientists in the 20th and 21st centuries to study them. The skeletal remains themselves told archaeologists an enormous amount about how these ancient Floridians actually lived. Many of the adults showed significant, sometimes severe dental wear, the kind of wear you get from a coarse diet and from using your teeth as tools, perhaps for processing plant fibers, softening hides, or working on cordage. Researchers found signs of arthritis in a number of individuals, along with healed fractures, indicating these people survived serious injuries and lived on afterward, sometimes for years or decades. One case in particular stood out to researchers and continues to be discussed as one of the most emotionally striking findings from the entire site: the skeleton of an elderly woman who had suffered from a severe, debilitating bone disease. Her condition would have left her unable to walk, unable to care for herself, and completely dependent on the people around her. And yet, the evidence showed she lived for a long time after the onset of her illness. That single fact tells us something profound about the Windover community. They were not simply a group of individuals surviving side by side. They were a society capable of long-term compassion, willing to care for a member who could offer little in return for years, in a world where every single calorie and every hour of labor genuinely mattered for survival. Some of the men at Windover stood close to 6 feet tall, unusually tall for a prehistoric population, and their bone density suggested a physically demanding but overall healthy lifestyle. Isotopic analysis of the bones, essentially chemical fingerprinting that reveals information about diet based on the ratios of specific elements absorbed into bone tissue over a lifetime, indicated a diet built around a mix of wild plants, fish, and small game, consistent with a hunter-gatherer society living along Florida's waterways and wetlands. Further analysis suggested the Windover people were not permanently settled at the pond itself. Instead, they appeared to be part of a nomadic or semi-nomadic group that moved around the greater Florida peninsula throughout the year, likely following seasonal resources, and returning again and again to this specific pond as a sacred and consistent burial ground for their dead. The textiles recovered from the site deserve their own moment of attention, because they quietly rewrote assumptions about how sophisticated prehistoric technology in the Americas actually was. Archaeologists uncovered fragments of woven fabric made from plant fibers, twisted and interlaced using techniques that required real skill, planning, and generational knowledge passed down through a community. These weren't crude scraps of bark or hide. They were deliberately constructed textiles, some fine enough to suggest specialized craftsmanship, and they remain among the oldest woven fabrics ever discovered anywhere in the world. Finding textiles this old, this well preserved, in North America completely upended the idea that early hunter-gatherer societies on this continent lacked complex material culture. It suggested a level of domestic sophistication, patience, and skill that many people simply didn't expect from a community living 8,000 years ago in a Florida wetland. The excavation process itself was slow, painstaking, and physically brutal for the researchers involved. Working in a waterlogged pond meant constant pumping of water, careful hand excavation in mud and peat, and a race against time. Because the moment ancient tissue was exposed to open air and oxygen, the clock started ticking on its rapid deterioration. Archaeologists often worked in wetsuits, kneeling in cold, murky water, delicately brushing away centuries of sediment from bones and tissue that could crumble or degrade within hours if not handled correctly. It was, in many ways, closer to an underwater rescue operation than a traditional dryland dig, and the success of the entire project depended on getting fragile organic material out of the peat and into controlled laboratory conditions before it was lost forever. All of this alone would make Windover an extraordinary archaeological site. Intact 8,000-year-old skeletons, ancient textiles, preserved organs, a genuine window into the daily life, health, and even the emotional culture of a prehistoric American community. But it's what came next, the DNA analysis, that truly transformed Windover from an incredible archaeological discovery into one of the strangest and most debated genetic mysteries in American prehistory. Scientists realized almost immediately that the preserved brain tissue represented an unprecedented opportunity. DNA, the genetic material that carries the biological blueprint of every living thing, degrades over time. It breaks down due to exposure to oxygen, bacteria, moisture, and heat. Under normal conditions, meaningful DNA extraction from remains this old, especially from soft tissue rather than bone or teeth, should have been essentially impossible. Genetic material this ancient, especially preserved in something as delicate as brain tissue, simply doesn't survive 8,000 years in a typical burial environment anywhere on Earth. And yet, because of the pond's unique anaerobic, low-oxygen chemistry, some of that genetic material had survived. To preserve this astonishing opportunity, researchers moved with extraordinary care. The brain tissue was removed directly in the field, immediately sealed into nitrogen-filled containers to prevent oxygen exposure, and rapidly cooled to extremely low temperatures. The samples were then transported to laboratories at the University of Florida, where they were frozen even further, down to nearly minus 100 degrees Fahrenheit, in an effort to lock the genetic material in place before any further degradation could occur. This was, at the time, a genuinely pioneering approach to handling ancient biological material. And the fact that it worked at all helped establish some of the very methods still used today in the field of ancient DNA research, sometimes called paleogenetics. When the genetic analysis finally began, researchers were specifically looking at two types of DNA that are especially useful for tracing human ancestry and migration. The first is mitochondrial DNA, which is passed down almost exclusively from mother to child, generation after generation, essentially unchanged except for small, slow mutations that accumulate over very long stretches of time. Because it's inherited maternally and mutates at a fairly predictable rate, mitochondrial DNA acts almost like a genetic clock, allowing scientists to trace maternal lineages back through thousands of years and connect populations across vast stretches of time and geography. The second type is Y chromosome DNA, passed down from father to son, which offers a parallel way of tracing paternal lineage. Using mitochondrial DNA extracted from the ancient brain tissue and later, more successfully from skeletal remains, researchers identified something that immediately caught the attention of geneticists and anthropologists around the world. Some of the individuals at Windover carried an extremely rare genetic marker known as haplogroup X. To put that rarity in context, haplogroup X is found in only a small percentage of modern Native American populations today, roughly around 3% by most estimates. It's one of the rarer maternal lineages found in the Americas, and its presence in a population this old, this far south, and this well documented, gave researchers a rare, concrete genetic data point for tracing the earliest human migrations into North America. It supported the idea that the Windover people descended from some of the earliest human groups to arrive in the Americas, part of the ancient wave of migration widely believed to have crossed from Asia into the New World by way of the Beringia land bridge, thousands of years before Windover Pond became a burial ground. Other genetic testing pointed toward additional maternal lineages present within the group, and researchers also found evidence suggesting a fairly closed, genetically isolated community. In other words, the people buried at Windover did not appear to be interbreeding significantly with outside groups. This suggests that during this period of prehistory, contact between distinct human communities across the Florida peninsula, or even across Greater North America, may have been relatively rare, or that this particular group remained fairly isolated by choice, geography, or circumstance for a very long time. Combined with the physical evidence from their bones, researchers were able to draw a picture of a genetically distinct, physically robust, and closely interrelated community, quite possibly an extended family group or clan, returning generation after generation to bury their dead in the same sacred pond. All of this on its own is remarkable. But then came the finding that turned Windover from a fascinating archaeological curiosity into a genuine scientific mystery, the kind of discovery that raises more questions than it answers. When researchers compared the ancient DNA recovered from Windover against the genetic profiles of modern Native American populations, and against the genetic data available from other known prehistoric populations across the Americas, they found something deeply unexpected. The people buried at Windover Pond did not appear to be directly related to any living Native American tribe today, nor did their genetic profile match up cleanly with any other well-documented prehistoric population identified anywhere else in the archaeological record. Let that sink in for a moment. Here was a population, clearly human, clearly part of the broader story of the peopling of the Americas, whose genetic descendants simply cannot be traced to anyone alive today. It's not that scientists haven't looked hard enough, or that the technology isn't good enough yet. The genetic markers found at Windover simply don't line up with the lineages carried by modern indigenous peoples of the Americas, nor with other ancient burial populations that have since been studied and sequenced. Somewhere along the long chain of human generations, stretching from that ancient Florida pond to the present day, a link appears to be missing. Researchers studying this puzzle have generally landed on two competing explanations. And honestly, both possibilities are equally fascinating and equally unsettling in their own way. The first possibility is that the direct genetic line of the Windover people simply ended. Their descendants, whoever and wherever they eventually settled, may have died out entirely at some point over the following 8,000 years. This could have happened due to disease, conflict, environmental disaster, or simply the slow, quiet extinction of a bloodline over enough generations, the kind of demographic dead end that has happened to countless human lineages throughout history without leaving behind written records to explain why. It's a sobering thought. An entire genetic lineage, once thriving enough to sustain a community for possibly hundreds of years, simply vanishing from the human family tree, leaving behind nothing but bones in a Florida pond as proof they ever existed at all. The second, and perhaps even more intriguing possibility, is that the Windover population went through what geneticists call a population bottleneck. This is a scenario where a group's numbers are drastically reduced at some point, whether through disease, famine, migration pressures, or some other catastrophic event, to the point where only a small fraction of the original genetic diversity survives into future generations. If this happened to descendants of the Windover people sometime after their community dispersed or declined, it's possible that the specific genetic markers scientists use to trace Native American ancestry today, the very markers that define the family tree researchers rely on, simply hadn't fully developed yet at the time these bottlenecks occurred. In other words, the genetic story of the Americas may have branched, thinned, and reshaped itself so significantly over thousands of years that certain ancient lineages, like the ones found at Windover, essentially fell outside the family tree that eventually produced today's populations, even if some faint thread of ancestry technically persisted somewhere along the way. Either explanation raises profound questions about how much we actually know or don't know about the deep history of human migration and settlement in the Americas. For decades, the dominant narrative was relatively straightforward. Humans crossed from Asia into North America via a land bridge across the Bering Strait, sometime toward the end of the last ice age, then spread southward and eastward across 2 entire continents, eventually giving rise to the incredibly diverse indigenous populations we know today. Windover complicates that simple, tidy story. It suggests that early populations in the Americas may have been far more genetically diverse, far more fragmented, and far more likely to have vanished, merged, or bottlenecked in ways that left little to no trace in the genetic record of modern populations. It's a reminder that the peopling of an entire hemisphere wasn't one clean migration event, but likely a messy, complicated, multi-wave process full of dead ends, isolated communities, and lineages that simply didn't make it to the present day. There's also something worth mentioning here about the limits of what science currently knows, because it's tempting, especially with a discovery this dramatic, to reach for sensational explanations. Some corners of the internet have tried to connect findings like the presence of certain rare haplogroups at Windover to fringe theories suggesting ancient transatlantic contact between early Americans and prehistoric European populations, sometimes referred to as the Solitrian hypothesis. It's important to be clear and honest about where the actual science stands. This idea is considered a fringe theory, and it is not supported by the overwhelming majority of archaeologists, geneticists, or anthropologists studying the peopling of the Americas. The mainstream, well-supported scientific consensus continues to point toward migration from Asia via Beringia as the primary origin for the ancient peoples of North America, Windover's population very much included. The genuine mystery here isn't about exotic origins from across an ocean. It's about the far more grounded, far more human question of what happened to an isolated, once thriving community whose direct genetic thread appears to disappear somewhere in the vast stretch of time between then and now. Techniques that have since been applied to other wet archaeological sites around the world, places where waterlogged, low-oxygen environments have preserved organic material far longer than anyone once thought possible. In many ways, Windover didn't just reveal secrets about one ancient Florida community. It helped rewrite the rulebook for what ancient DNA research could even attempt to accomplish. Today, the story of Windover Pond continues, but in a very different form than the frantic, groundbreaking excavations of the 1980s. The site itself is now protected. In December of 2013, it was purchased by the Archaeological Conservancy, a national nonprofit organization dedicated specifically to acquiring and preserving significant archaeological sites across the country, ensuring that Windover Pond will never again face the risk of being paved over, developed, or disturbed without careful oversight. Public access to the site itself is deliberately restricted, both to protect its long-term preservation and out of respect for the fact that this is ultimately an ancient burial ground. Further destructive genetic testing at the site is now also carefully limited by federal law, specifically the Native American Graves Protection and Repatriation Act, often referred to simply as NAGPRA. This law exists to protect Native American human remains and cultural items from being disturbed, studied, or removed without appropriate consultation and respect, recognizing that these are not simply scientific specimens, but the actual physical remains of real human beings with descendant communities and cultural significance that deserve to be honored rather than endlessly excavated in the name of research. As a result, as of recent years, no major new destructive DNA analyses have been conducted at Windover, and future research at the site is increasingly likely to rely on non-invasive methods, such as ground-penetrating remote sensing technology, which can help researchers map unexcavated areas of the pond and surrounding land without ever disturbing the remains themselves. That means, in a strange way, that the mystery of the missing genetic descendants at Windover may remain exactly that for a long time to come, a mystery. The tools available to modern science are extraordinary, but the ethical and legal frameworks that rightly govern how we treat ancient human remains mean that Windover Pond will likely keep some of its deepest secrets for the foreseeable future, protected as much by law and respect as it once was by peat and pond water. And maybe that's fitting. This was, after all, a community that clearly cared for one another, deeply enough to sustain a disabled elder for years, deeply enough to carry their dead into the same sacred pond generation after generation for possibly centuries, weaving fabric and preparing careful burials for people whose names we will never know. They didn't build pyramids or leave behind written language. They left behind something arguably more intimate, their bodies, their brains, their genetic code, and an entire unanswered chapter in the deep story of how human beings came to spread across 2 continents. 8,000 years later, sitting quietly beneath a protected pond in Florida, the people of Windover are still teaching us, not just about ancient diets, ancient injuries, or ancient burial customs, but about the sheer scale of what has been lost and forgotten across the vast stretch of human history. Entire communities, entire bloodlines, entire ways of life that thrived, cared for their sick and elderly, buried their dead with intention and ritual, and then, for reasons science may never fully uncover, simply disappeared from the genetic record of the world. It's a humbling thought. For every population whose descendants we can trace clearly through history and DNA, there may be countless others like the people of Windover, real human beings who lived, loved, suffered, and cared for one another, whose entire genetic legacy has quietly vanished into time, leaving behind nothing but bones in a swamp and a handful of stubborn, patient scientists determined to listen to what those bones still have to say. Think about everything that had to go exactly right for this story to reach us at all. A pond had to form in precisely the right location, with precisely the right chemistry, low in oxygen and rich in peat, capable of halting decay in its tracks. A community had to choose that pond generation after generation as a place of reverence for their dead, staking bodies into the mud in a ritual they could never have known would double as an act of scientific preservation. That pond then had to sit undisturbed for 8,000 years, surviving hurricanes, droughts, floods, and the slow creep of Florida's changing landscape until, by pure chance, a developer decided to build houses on that exact patch of land. And finally, a single construction worker had to notice something unusual in his shovel and make the choice to stop and speak up instead of clearing the pond and moving on with his job. Remove any one of those variables, change any single link in that chain of coincidence, and the people of Windover would still be resting anonymously beneath the mud, their extraordinary story never told, their brains, their DNA, their entire biological history lost forever without anyone ever knowing what had been there. That's really the deeper takeaway hiding underneath all the science, the haplogroups, the isotopes, and the peat chemistry. History is fragile. Most of it never survives long enough for us to study it at all. The vast majority of human beings who have ever lived on this planet left behind no records, no monuments, and no trace that modern science can ever recover. Windover Pond is the rare, almost accidental exception, a place where the ordinary forces of decay were paused just long enough for us to catch a glimpse of people who otherwise would have disappeared completely from memory, the same way their genetic descendants apparently have. So the next time you hear about ancient DNA rewriting history, or a new discovery challenging what we thought we knew about early humans in the Americas, remember Windover. Remember a backhoe operator standing in Florida mud, holding a skull that shouldn't have still existed after 8,000 years. Remember an elderly woman, cared for by her community long after her body had failed her. Remember a family, a clan, or perhaps an entire small nation of people, staking their loved ones gently into a quiet pond, never knowing they were creating one of the greatest scientific time capsules in American history. Their names are gone. Their language is gone. Even their direct genetic line, as far as science can currently tell, appears to be gone. But for a little while, buried in Florida, peat, and unlocked by modern genetics, their story came back to the surface, and now it belongs to us to remember.